So in the session, we study 5 axioms, not 4. Every axiom or every group of axioms give you a little bit more. So we start from a preference. Preference means there are a number of possible outcomes, and sometimes you prefer A over B. That's it, nothing else. So a very, very general structure. First axiom is completeness. The first thing we would like to require is that whenever the agent is given 2 options, it will have a preference for one over the other. Second axiom is transitivity. So we would not like to have cycles of inconsistency, like A over B, B over C, C over A. As soon as you embrace those 2 requirements, you can prove that your preference can be represented as the maximization of some function. So there is a function that you measure, is like a number that you attribute to every outcome, and then you can say that agent is maximizing that function. So that's a representation theorem that gives you a way to understand how the preferences of that agent are structured. And you just need those 2 axioms. If you have mixtures of events, so you don't have only events, but you also could have 50% of this and 50% of that, then you would like a bit more of structure. In particular, you will start asking yourself, how do my utility, this function, this number that you attribute to events, relate with the weights of the mixtures? And there are typically 2 extra axioms that you take. One is continuity. That means utility will vary continuously with the mixtures. More technically, it means if I have a x I prefer over y that I prefer over z, there is a mixture of the extremes that is equivalent to the middle one. That's continuity. And then the fourth axiom, independence, is that if I prefer A over B, and I do a mixture of A and B separately with the third component C, if I prefer A over B, I would prefer mixture of A and C over mixture of B and C. So by mixing with the same component both, I keep the preferences. If you assume those 4 things, now you turn this number, this utility over the events, into an expected utility, which gives you much more structure. At that point, you could be thinking the events that I'm weighting are trajectories over time. And at that point, you would like to say, oh, but there is some temporal structure over this. And I would like my utility over a trajectory to decompose over the different points in time. And at that point, there is this 5th axiom. The way I weight value today and tomorrow is proportional to the way I weight the change in value between a year and 1 day. So there's a proportionality. As soon as you also embrace that 5th axiom, you can decompose the utility over a trajectory over a sum of rewards at every time point with a discount that is this proportionality factor. So basically, what you are doing is you start with a preference that is very unstructured. You assume 2 things, continuity and transitivity, and you turn that preference into an ordinal utility, a number that orders possible events. Then you assume 2 more things, continuity and independency. You turn the ordinal utility into an expected utility, which is much stronger in the type of interpretation you can get out of it. And then if you assume the 5th axiom, you turn the expected utility into an expected sum of future rewards. And that brings you directly into the domain of RL. So what is nice is that you are now not simply maximizing the discounted future rewards because it works. You are doing that because you are assuming these 5 things and you think it's reasonable to do so.